It's just a science project.
Silent breed is people!
A doctor friend once said the same thing to me. Frankenstein was his name.
It's alive! It's alive! It's alive!
That sounds like something out of science fiction.
Please explain to me the scientific nature of the whammy.
You live in a spaceship, dear.
So? Yes, science!
Program complete. Enter when ready.
Hello and welcome to episode 262 of Science on Top. Today is Sunday the 30th of April 2017. I'm Ed Brown and on the show today is Penny Dumsday.
Hello.
And Lucas Randall.
Hello.
And today we'll be looking at growing sheep in an artificial womb and looking for life on Europa. But first, Lucas, the Cassini probe, which has been studying Saturn and its rings and moons, it's now running out of fuel, and as it comes to the end of its life, it's begun some risky but very cool manoeuvres. What's it doing?
Well, before we get to what it's doing, I think we need to take a moment. We've got to take a moment and step back and just go, what an awesome craft Cassini is. I've ranted about how awesome Cassini is before. I think Cassini and Hubble are probably my two favourite scientific instruments, just because of the discoveries that they're giving us. And I've got rotating backgrounds on my computer and my phone and stuff like that, and Cassini's images of Saturn and its rings, particularly backlit by the sun and whatever, feature pretty heavily in those because they're just amazing. And if you've never looked at Saturn through a telescope, there's so many people I've spoken to got into stargazing after seeing Saturn through a telescope because it's just awe-inspiring. It's incredible. It looks like someone's put a photo of Saturn at the end of your telescope, and you're going, is that real?
I've heard people actually ask, did you put a sticker or something on the lens?
Because it's just, the photos that you see, the Cassini images, which look more or less black and white most of the time. Sometimes there's some false color in there, and then of course you've got the images of the really cool storm at the North Pole. This kind of this hexagonal storm, which is just so bizarre, So and there's some colors in that, but basically, a lot of the images that you see of Saturn are pretty much grayscale, black and white sort of images. And then you look at it through a telescope, and that's exactly what you see. And I think if as a contrast, if you look at Jupiter through a telescope, it can be a little bit disappointing because you're used to seeing these incredible rich colours that are in photographs that we've seen, and a lot of the amateur astronomers have got quite rich colour images of Jupiter, but they're usually, stacked images. They've got hundreds and hundreds of captures that have been overlaid on top of each other, and that's what gives them that vibrancy of colour. So when you look at it through a telescope, it's quite bland. But Saturn, it is what it is, and oh my God, it's just gorgeous. So Cassini has been there for pretty much most of my adult life, to be honest with you. It's kind of, it's been going for a long time. And it was always going to get to this point. It was always going to run out of fuel. I think if you look at its journey and what it's done over the time and the discoveries that it's had, they're awe-inspiring in themselves. But what it's about to do and this final mission, as they're calling it, is as you said, it's quite daring because they're basically threading the needle where they are throwing this thing into these quite eccentric orbits around Saturn, which are kind of squeezing it closer and closer, and then taking it within the rings of Saturn, in between the rings and Saturn itself, which is pretty mind blowing because we're quite a way away. Like in terms of imagining trying to pilot a remote control car that's just at the end of your driveway. That's pretty hard when you can't see it very well. But you do it from what is it? I think here we go. Here's a great quote. We're going to be going 700,000 miles per hour, which is 112,000 kilometers per hour, into a 1,200 mile gap, or a 1,900 kilometer gap. And oh, by the way, we'll be driving this thing from 1 billion miles away.
1 billion.
1 billion. That was Earl Mays from Cassini's project manager at JPL. So, it's pretty amazing that they're able to do this from so far away, and it really is a credit to our understanding of orbital mechanics to be able to do that. But they're kind of expecting big things. They're expecting that this final mission will reveal details about Saturn and its rings that we'd never seen. Obviously, we don't know what those details are yet, but the speculation and the expectations are really quite high that they'll get possibly some of the coolest images of the entire mission. And reveal structures that we've not been close enough to see before in the rings. And some of the structures that we've seen previously, these resonance patterns that we've seen in the rings and little ripple effects and all sorts of things that are the results of interactions between the ring, some of the rings with other rings, or the rings with other little moons and this sort of thing are really quite cool. But to be able to get even closer to see those things is really just awesome. And then at the end of it, they're going to death dive it into Saturn. So it's kind of like, and on one hand it seems like a sad end to the thing, but I think it's a very fitting end. That the planet, this gas giant that it spent most of its life orbiting, at the end it will become one with it, and I that's kind of poetic, I think.
It's also obviously a environmental protection mechanism, because the idea is it'll burn up in Saturn's atmosphere and disintegrate, rather than contaminate a moon or something with some trace extremophiles that have survived the 20 years that it's been there. So
yeah, absolutely. And this is one of the things that they have to think about is we now know that, for example, Enceladus is one of the moons of Saturn that is certainly a candidate for some forms of life. We don't know yet whether it does, but certainly it has liquid water, and that's one of the things that seems to be required for life here on Earth. So the chances are that it's certainly possible that there may be life there. And if we left it sort of in an uncontrolled orbit, and remembering it is going to run out of fuel, then eventually there's the horrible possibility that maybe it would collide with something, and there are lots of somethings around Saturn. A lot of there are many moons around Saturn. Many of them are quite small, so you'd have to get it into a very distant orbit to ensure that it wouldn't hit one of those things. But there's also, there's always the possibility that something could collide with it that comes in. It's distinctly unlikely, but it's possible. And if that does happen, it could become a part of the ring system itself, or heaven forbid, it could actually rain, debris down on any of the moons, any of the many moons. So you have to think, okay, well, if there's a possibility for life, we may end up seeding that life, or at worst, we may end up interrupting life that's developing there. So they have to take precautions, and this is such a precaution. You've got a gas giant. Gas giants have quite a lot of mass. When you have something that's got a lot of mass, it has pretty crushing gravity. So you death dive a probe such as this into its atmosphere, and sooner or later it basically just gets obliterated into just gas. And we're pretty sure that Saturn itself is probably not going to host any life, or not life that we've ever come across before. Anything, maybe some sci-fi type floating in the clouds, things. But I made.
In which case, we've just made first contact.
yes. Here, have our probe in the gob. But as I said, I think we haven't got long. I think it's sometime in September, from memory, that it's going to take its final plunge. And then, it's doing these loopings around 20 something times, 22 times or something like that. So, not long to go, and really just do pay attention to the coverage up until then, because I'm quite sure we're going to see some spectacular images coming out of this.
Well, we've already seen some really cool photos of the closest that we've ever had photos of Saturn, thanks to the first of the insertions in between the rings and Saturn. But I just think also Cassini is another tribute to NASA's ability to make things last. It's the same with Hubble and with Mars rovers. I mean, this was launched in 1997, and it took 7 years to get to Saturn, and it's been going non-stop ever since then. And it's going to keep on sending back data right up until it's finally obliterated in Saturn's atmosphere.
Yeah,
which is
absolutely.
Just so cool.
And speaking of sending back data, it recently, during the first insertion between the rings, there was a period of time that it was out of contact, and that's pretty rare with Cassini, from what I understand. But there was a period that it was out of contact because there was a maneuver that required maybe a rotation, or it got behind Saturn or something like this, and that was a little bit scary for the mission scientists on this one, because once you take you do anything to a spacecraft that means it can't talk to you, it means if it doesn't sort itself out the way that it was designed to do, then you may never ever talk to it again. And of course, I'm reminded of the Philae probe when it landed on the comet, and then we just never heard from it again. I think there was some sort of beacon at some point, and we got all excited thinking that maybe it was going to talk, but it never talked. It did spawn a very cute cartoon, though, if you recall that little the cartoon drawing of it, sort of snoozing.
Yeah, it's an extraordinary thing that we're doing. I think it's definitely worth following all the stories that we hear back. But we'll keep an eye on it and see what happens. Okay, Penny, let's talk premature babies. Obviously, a prem baby is at a very high risk of developmental problems and death. But when it comes to baby sheep, lambs, there's some exciting work being done to create an artificial womb that can keep a unborn baby almost essentially until it's ready to be born. It's very, very cool and kind of sad as well.
Yeah, I was saying to Ed just before the show how I quite like this story, but I also found it quite affecting, just thinking about everything, and not just human babies, but even the if you have a look at the article we'll link to, the visual of the sheep, the little lamb. So before we start thinking sort of Brave New World style literal test tube babies, this is not so much a replacement for a pregnancy, but almost an ultra sophisticated sort of incubator, rather than having babies in those intensive care beds, to keep them in an environment that is more like what they would naturally be experiencing, at maybe 22 weeks gestation. So the research was done with lambs, and if you have a look, if the artificial uterus itself, it sort of looks just like a gigantic plastic bag with a little lamb fetus inside it. And what's really clever about it is all the different tubes. If you think about what's going on as a baby mammal grows in utero, there's blood going in and out, oxygen going in and out with the blood, wastes getting filtered. So it's quite a complex environment. The baby developing drinks the amniotic fluid and excretes the waste, into urine and so on. So it's quite complex. And apparently one of the big problems with developing this kind of system is the pump, because to oxygenate blood and then pump it back into the body takes a bit of pressure. And that's fine for an adult, but not for a developing fetus. So one of the keys to this new system is a different way of oxygenating the blood that means that it doesn't need a pump. The heartbeat of the fetus is enough to circulate the blood and so on. And wow. I think this is really exciting. So apparently lambs that were just gestated for part of their development in this system did just as well as lambs that were born at the same time. But I don't know how to... They all gestated for the same time, but some spent 4 weeks in the bag. Sorry, I can't express that. And they were doing just as well, which is interesting because some of the problems associated with prematurity are things like lung development and so on. And because this keeps fluid in the lungs longer, it might be more more conducive to lung development. So it's actually really, really, really exciting. I guess the thing that affected me emotionally was I can't imagine what it would be like to have to make decisions about reviving a really, really, really premature baby. It's fantastic that something like this could give hope, but I don't think it will be human tested for several years, you know.
No,
then.
Of course not.
And even then it wouldn't be a magic bullet, especially because, I mean, I'm going to guess that only certain people in certain wealthy countries are going to have access to technology like this. However, I don't know. I mean, I guess that's the thing about everything. I think there's something about the picture of the little lamb that I found quite moving.
It is kind of cute. It is, yeah.
It is cute, isn't it?
But also, I mean, it's very much, and I apologise for this phrase, it's very much in its infancy.
Oh, God.
We often talk about mouse studies and everything and how they're not direct analogues for humans. Well, lambs are not direct analogues for humans either. And so there's a long way to go in testing on primates as well and before you get to humans. It's an encouraging thing if you have if you have a baby born 4 months prem and you can then keep them going and develop them like a normal baby, that's extraordinarily cool. There's a degree of science fiction when they talk about, you know, this is unlikely to ever replace a human pregnancy altogether, but pregnancy is risky for mother and baby, and it might become a point 50 years down the track where you're safer to put the fetus into a bio bag, as they call it, an artificial womb, and grow it there, rather than putting the mother and baby at higher risk of natural pregnancy. It's something to think about.
It's something to think. It's interesting, isn't it? Because that thing reminds me of formula milk, which was seen to be, you know, better and safer and more hygienic and more scientific. And it turns out that there's stuff in breast milk that we really, you know, we don't fully understand, you know, all the immune factors and so on that get passed on. And you do wonder, like, with a human pregnancy, what's going on that we don't understand? Because, like, I'm not going to lie, I didn't enjoy being pregnant. I was terrified of huge amounts of it. It's a very interesting thought, but but
still very early days. So
very, very early days.
We'll see what happens, but I think it's exciting in any case, just to have actually been able to replicate a womb and successfully deliver baby lambs. It's very, very cool.
I agree.
All right. Well, speaking of life, Lucas, it's official. NASA and the ESA are looking for life on Jupiter's fourth largest moon, Europa. Or at least they plan to be in 2025.
I'm not sure. I'm not sure whether they're expecting to find life directly with this mission. And to be honest with you, details are a little bit scarce on this for me from what I've read so far. It was pretty exciting to see this. This was announced about a week ago. And it's a joint mission between the NASA and ESA, which is the European Space Agency, which is a good idea because it means that they can pool resources, and at a time when funding's sort of, you know, pretty hard to get, it's an intelligent way to do it. So, you know, it's pretty exciting to see that this mission is being planned at the moment. It'll be sometime in the mid-2020s that it would launch. And the projected timeframe for the mission is something like, you know, 6.5 years or so. And the first 5 of which will be just getting there. And then a fairly short mission once it is there. It'll be in 2 parts, at least that's the intention right now. And what is exciting about this is that it involves a lander. So that's been something that's been thrown around for ages and ages and ages, that, you know, if you wanted to explore Europa, realistically, you need to get to the surface. And I've certainly read many, suggestions about ways that they could get through the ice to get down to the ocean, this massive, massive ocean. I mean, the amount of water here is astonishing. We're talking about, significantly more water than is in all of the oceans on Earth under the ice of Europa, and an ocean
twice as much.
Yeah, and it's something like 10 times as deep as the deepest parts of the ocean here. Now, bear in mind that Europa, the moon itself, is much, much smaller than Earth, so that's, it might sound a little bit contrary and hard to think, well, how can there be twice as much water but 10 times as deep? Because, our oceans are not really all that deep. They tend to only be a few kilometres deep at their deepest part. So this has two parts. It has a lander and it has an orbiter. So they'll travel there together, and then the orbiter, the lander will eject and basically land and rove around. Now, this is where it's a little bit vague to me from what I've read so far as to what the lander will do. It will roam, so it's some sort of rover, but there's nothing that I've read that indicates that it's going to try and drill or melt its way through ice or any of those other things that I've read about in the past with ideas for missions to Europa. So I guess the idea... Go on.
In the New Scientist article, they say that they'll plant a lander on the moon's surface for 35 days to sample and screen material for traces of life. So presumably it will do some small digging and sample retrieval and presumably analyse it there on the spot. So. Yeah,
which is exactly what I was going to say. I assume the intention is just to look for, any kind of sign of life's processes on the surface, because we're not really expecting there to be life on the surface. The most likely candidate for life in Europa is in the oceans, because they're liquid water, and that's as we talked about just before with regard to Enceladus around Saturn. That's really we tend to know that on Earth, wherever there's liquid water, there tends to be life. So that's why it's of interest. So it'd be really cool if the lander had some kind of capacity to get through the ice. But there are lots of fissures on the surface of Europa. In fact, that was one of the things that sort of tipped us off to the fact that it was an icy body with an ocean body beneath it in the first place. Is these fissures which are I guess are a little bit like the pancake ice that forms on the ocean in Earth in the Arctic regions, or at least up until recent years, less and less than that probably. But so there were certainly strong signs once they saw the surface of Europa that there was liquid beneath it, and we don't know for sure at this point what's maintaining the ocean in a liquid state. It's assumed a very much part of it is the gravitational interactions with Jupiter and basically this tidal squeezing of Europa. That if you can imagine anything that you exert friction on, you effectively create heat as a response to that. So that's very likely to be a big part of it. But there may also even be if there is any kind of rocky body at the centre of Europa, it may well have some geological activity, maybe geothermal vents, that sort of thing. And they're another very interesting idea because, as with Earth, when we have geothermal vents, they tend to be teeming with life, even at the deepest parts of our oceans. So as I say, if you've got a lander that's just scooting around the surface, you'd probably try and find some of these fissures and look for any biosignatures or whatever that may have been ejected or seeped out or something like that. So, I'm not really sure. But the orbiter is interesting as well. The orbiter obviously would be festooned with various instruments to search for biosignatures as well. But that's sort of what I meant right at the beginning, that it doesn't seem to me that it's a direct, life detection mission.
Yeah.
It seems to be its purpose to look for signs of life, but it's not the life we.
Oh no!
I'm not going to go there.
But not as we know it.
Yeah, I'm excited about it, but I'm a little bit mixed about it as well, because it could have been so much more.
Yeah. And we've talked about a submarine exploring deep down in that ocean and things like that, but. Who's going to pay for that?
There's also, I also wonder whether the orbiter, whether they might include any instruments that could be used to sample any ejections from Europa, because we have seen that before as well. We've seen plumes of ice being ejected out of Europa, and that was also one of the signs that there was liquid water there, just like on Enceladus around Saturn, where we've got these tiger stripe features on its south pole where it's basically got an ice volcano of sorts, where it's basically pluming out this water, which goes straight from the liquid form into the ice form. It sublimates straight to ice. So we've seen that before on Europa. So if you were able to sample that, then that might also be a very good way of looking for biosignatures. But I'm not sure whether the orbiter will have that capability as yet.
I think also it's very early days now anyway. I'm sure a lot of things are going to change while they're building it. We can't afford this, or we can afford another instrument, or someone wants to try something else. For instance, the other thing that kind of worries me, especially after we've just been talking about Cassini's end of life, at the end of the mission, they're going to crash the orbiter into the moon, which is not a gas giant that's going to completely obliterate any trace of life or anything.
That jumped out at me as well. And I guess this means that there's been, I think we've covered on the show before, the possibility of life on Mars, and the fact that they've had to deliberately steer the various rovers away from those areas. They've found areas and gone, well, we could actually send Curiosity there to have a look, but we're not going to do that because Curiosity wasn't treated to the level that it needs. It wasn't, built in a room that was effectively zeroed
sterile
out the chance zeroed out the chances of microbial life to the level that would be satisfied that we couldn't actually contaminate the area. So that means that if they're planning to do that with A, the lander, and B, the orbiter, because they're talking about ploughing the orbiter into it and then studying the ejector. In a similar way, I guess, to that. There was a mission to one of the comets to do that. I can't remember the mission now, but there was one where they basically ploughed this thing into the comet, and then wanted to test the samples of dust and ice particles and so forth that flew off it. I've got a mental block.
We've done it on the moon as well. There was a similar mission.
We have actually, yeah, good point. We have done it on the moon as well. So that's that was mentioned in with regard to this orbiter as well. So if they're doing that, then they would have to have treated it to that level that they know it won't be able to contaminate Europa. So but with everything right now, it comes down to one key thing, and this one is the comment at the end of the New Scientist article, which is the budget request is now with the president. That's of the United States. So,
we will see what happens. Anything can happen.
Anything can happen. Anything.
All right. And I think we're done. If you want any more information about the stories we talked about, or if you want to get in touch, head on to scienceontop.com/262. And also check out our social media information and leave us a comment. Don't forget, check out scienceontop.com/donate to pledge some money our way. You can pay on a per episode basis, and you can set a limit to how much you want to pay each month. We're really, really grateful to everyone who helps us pay the bills and keeps the show running. Thanks for joining me today, Penny and Lucas.
Thanks, Ed.
You're welcome.
This episode was edited with fanatical fairness by Marcos Benamu. Thank you everyone for listening. We'll be back again next week, putting science on top of the agenda. Join us then.
Cassini's grand finale is a brand new adventure. 22 dives through the space between Saturn and its rings. As it repeatedly braves this unexplored region, Cassini seeks new insights about the origins of the rings and the nature of the planet's interior, closer to Saturn than ever before. On the final orbit, Cassini will plunge into Saturn, fighting to keep its antenna pointed at Earth as it transmits its farewell. In the skies of Saturn, the journey ends, as Cassini becomes part of the planet itself.